As a quick review on point slope form, we want to remember that mathematicians are not very creative with their names. So in order to graph a line in point slope form, we need a point and we need the slope of the line. This thing right here is point slope form. The things that are written in red are numbers that will be replaced with the ordered pair. For example, if I had an ordered pair of 2, 3, my y value right here would move and replace this y value right there. This x value right here would replace this x value right there. I also write point slope form in this spot with open boxes to remember what I'm going to be filling out with the ordered pair. Be very cautious about the fact that the numbers in front here are negatives because it's a very easy mistake to make. For this equation right here, I want to find what the slope is and what the point is that's letting us write this in point slope form. When I'm working with problems like this, the thing that I recognize first is almost always the slope, which is the number that's outside of the parentheses. So the slope of this line is 1/3. Now the ordered pair that we're working with is a little bit harder to work with. Remember that when you're working in point slope form, it is y minus something and x minus something. So you're almost always going to do the opposite of whatever this sign is. So if my x value here is -9, that means the x value here is a positive because we're already subtracting. If my y value is +6, that means the ordered pair is -6. So this line right here has this slope, and it goes through this point. For the problem down on the bottom, let's do the same goal. The slope is always the coefficient that's in front of the parenthesis. In this case, it's -1/4. Our ordered pair that we're working with here, x minus something, well, minus a -2 made that positive. And my y value, it's already a -1. Therefore, this value is opposite as a +1. Now, what's interesting about point slope form is that we also can write point slope form into other forms. So what I'm going to do with these two problems is I'm going to convert them to slope-intercept form. And if we remember, slope-intercept form has y by itself. So what I want to do is I want to get rid of everything that's on the same side as the y. Well, in order to do that right away, I have to do the distributive property on the left side. So that makes y plus 6 equals 1/3 x. 1/3 of 9 is 3. And then I'm going to subtract 6 from both sides. Now you have to be very cautious here. When I'm subtracting a regular 6, I need to subtract only the regular numbers with each other. And I get -3 minus 6 more is -9. And so I have this line and this line are the same. This is slope-intercept form, and this is point slope form. For the problem on the right, we can do it again. And now this one's going to show us why point slope form might be better than slope-intercept form in some cases. So I would do y minus 1. I'm going to leave that. And I'm going to do -1/4 times x. Stays like that. And then -1/4 times 2 becomes -2/4 or -1/2. So I have this weird problem already where I have a fraction with another fraction in my problem. From here, I'm going to add 1 to here, and I get y equals -1/4 x. -1/2 plus 1 whole will be +1/2. And now I have this line is written in slope-intercept form. But in this case, point slope form is actually a lot easier to work with. So if we look at the problem on the left, Slope-intercept form looks pretty clean, pretty easy to work with, probably the one we would choose. For the problem on the right, point-slope form actually looks a little bit cleaner, a little bit easier to use. So one of the important things is being able to convert back and forth into and out of point-slope form to make sure we're using the best line for our problem. For my last problem, I'm going to try to take this line and write it in point-slope form. Well, in order to write something in point-slope form, I need a point, which I have 2 of, and then I'm going to need the slope as well. So the slope for this line, I'm going to do rise over run. So I'm going to do up 1, 2, 3, 4, and I'm going to go over 1, 2, 3, 4, 5, 6. So my slope is 4/6 or 2/3. Probably going to work with 2/3 because it's usually easier if they're simplified. As a reminder, point-slope form is written in this form. Probably getting a little sick of seeing this form here. And I'm going to be filling in the x1 and the y1 with the ordered pair we're working with. In green, I'm going to write using this point. And as a reminder, you can use either point for point-slope form. So I'm going to do y minus a -4 minus a -4 is +4 equals m, which is my slope of 2/3, parentheses x minus 0. And now I have, this is written in point-slope form. I also can write point-slope form using this point, and I'll do that in red. I have y minus 0 equals 2/3 parentheses x minus 6. Now the last thing I want to do is I want to show you why you can use either line or either point to graph these lines. And I'm going to do that by doing the distributive property and turning these into slope-intercept form. So here I have y plus 4 equals 2/3 x plus 0, and I can actually ignore that. So I'm going to subtract 4 from both sides, and I get y equals 2/3 x minus 4, which makes sense because we have our minus 4 right here, and our slope is 2/3. So that's slope-intercept form. That's what we were working with before. And if we noticed, this equation gave us point-slope form. Let's see if that happens over on the right side. So subtracting 0 can be ignored. So it's y equals 2/3 x minus 2/3 of 6, you probably guessed it, is -4. So we notice that no matter which point we used, we still got back to the same slope-intercept form equation. Like I said in the original video, point-slope form is pretty tricky to get used to. The good news is we're still working with the same lines that we've been working with. None of that has changed. We're just using a new equation to help us graph a little bit easier. As always, if you have any questions, please let me know.